Assalamualaikum everyone, welcome back to this channel. So in this video we are going to discuss about the chapter of adrenergic antagonist. So in the previous lecture we have discussed about the adrenergic agonist. Now we are going to start the chapter of adrenergic antagonist. So adrenergic antagonist. Anta means to oppose, and agonist means the substance which stimulate the adrenergic activity. So it is going to oppose it, mean they are blocking the adrenergic activity. So they can also be called as adrenergic blockers. So they are blocking the adrenergic receptors on it. And we can say they are sympatholytic. So sympatho mean they have a sympathetic nervous system activity, and lytics mean breakdown. So they are actually neglecting, or they are actually degrading the activity of sympathetic nervous system. So what are the activities of sympathetic nervous system? So it includes the increase in the heart rate, it includes a decrease in the GIT mortality or GIT movements, and decrease in the urination, and it increase the vasoconstriction in the blood vessel, leading to increase in the blood pressure. So these are all the sympathetic activities. Now in sympatholytics we are just opposing all of these fractions. We are decreasing heart rate, we are dilating blood vessels. In short, we are decreasing our blood pressure. So how they work, how the adrenergic antagonists work? So actually they are blocking the receptors. So this is the neuron from which your norepinephrine will release by the fusion of the vesicle. So this vesicle fuse with it and release epinephrine. Okay, so now what is going to happen? This epinephrine will bind with two receptors. So this is the alpha receptors, and this is the beta receptors, which are the two types of adrenergic receptor which are present in your body. Alpha 1 receptor has further two types, alpha 1 and alpha 2. Beta has three types, beta 1, beta 2, and beta 3. We all have discussed this discussion in the chapter of adrenergic agonist. Now what is going to be happen, we give that patient antagonist. So here is this antagonist. So what is the function of this antagonist? So actually this is blocking the alpha and beta receptors. For what it is going to do, it will bind with both of these receptors and going to block it. Now it has blocked this active site, and it doesn't allow the epinephrine or the adrenergic agonist, which is in such shape. So it will never allow antagonist. This is the agonist, and this is the antagonist. So it will never allow epinephrine to bind. It throw the epinephrine out, it will throw the agonist out of it, and doesn't allow them to bind. Instead it bind itself with them and block these receptors. So as a result, your sympathetic activity decreases. Now we have two types of adrenergic antagonists. So first is the alpha adrenergic agonist. एड्रेनर्जिक एंटागोनिस्ट कह सकते हैं, या आप ब्लॉकर्स कह सकते हैं. एंड सिमिलरली बीटा एड्रेनर्जिक blockers. So now let's discuss about the alpha adrenergic blockers. So your alpha adrenergic blockers are the substances. So first you will write the definition of it, that alpha adrenergic blockers are the adrenergic antagonists which only binds to alpha receptors. So alpha receptors are further of two types, alpha 1 and alpha 2. So they bind with them and decrease the sympathetic activity. Now there is further two types of adrenergic alpha adrenergic blockers. So they can be selective and non-selective. So they can be selective and they can be non-selective. So the words selective mean that they will selectively bind with uh, uh, with uh, uh, with alpha 1 and can be bind with alpha 2. So there are some drugs which only bind to alpha 1, and there are some other drugs which can only bind to alpha 2. But non selective drugs are those which can bind with both. They can also bind with alpha 1 as well as they can also bind with alpha 2. So it's mean the selective blockers are very highly specific. They have only one subtype of alpha on which they can bound, but non-selective have no particular type of relation. They can bind with alpha 1 as well as on alpha 2 receptors. Okay, now we are going to discuss that what are the selective drugs and what are the non-selective drugs. So your selective drugs is very simple, that your alpha 1 selective drugs are of three drugs are given here in a pair. So first drug is terazosin, second is dosazosin, and third drug is parazosin. So they all end in a word which is zosin. And the alpha 2 selective drug is yombin. Okay, now so these are the selective drugs. Alpha 1 selective drugs like terazoline, doxazoline, parazoline, they only bind with alpha 1 receptor and show their particular kind of activity. And yombin is only bind to alpha 2 receptor. It doesn't bind with alpha 1 receptor, so it only bind with alpha 2. Now, the non-selective drugs can bind with both of them. And what are non-selective? Two drugs are given in it. First is phenoxybenzamine, phenoxybenzamine, okay, and the next drug is phentolamine, phentolamine. So these are the two drugs which bind with both of the alpha receptors. So now we are going to study all of these drugs one by one. We will study their mechanism, we will study their adverse effect, and we also study about their therapeutic uses. So first of all, I am going to start the lecture with the non-selective drugs which can bind with both receptors. Now first of all, start with phenoxybenzamine drug. So this is the phenoxybenzamine drug. So first of all, I have written that it is non-S mean selective. So it is non-selective. So due to its non-selective or non-specificity, it, it can bind with both of the alpha 1 as well as on the alpha 2 receptors. Now other thing is that it is non-competitive. Always the thing which is non-competitive means it is not going to fight. So how it is going to fight? So actually, in order to bind with these receptor and in order to block these receptor, antagonist has to fight, and then it will block the receptor. So this antagonist fight with two-person. First person is norepinephrine, which is released by it, and second is the agonist, which you can give to the patient. So the drug which is non-competitive, so this drug can easily bind to that receptor. The non-competitive drug has to not a need to fight with the both of them, but a drug which is competitive, it has to fight with two persons and then it will bind it. So your phenoxybenzamine is non-competitive, so it means it doesn't need to fight with the two-person, with the epinephrine or with the agonist drug. So therefore, it can easily bind. And its duration, it means, let's suppose if you eat a drug of phenoxybenzamine at 6 o'clock, so the next day at the 6 o'clock its duration end. Mean its duration is about for 24 hours. So in these 24 hours your heart rate will decreases, your blood pressure remain decreased, and you have this kind of activity, sympatholytic activity remains in yourself from 24 hours. Now let's discuss about their mechanism. As I have written, they can bind with alpha 1 as well as of the alpha 2. So first of all, alpha 1 receptor are present on blood vessels, so therefore they on the smooth muscles of these blood vessels, so they will bind with them, causing vasodilation, and due to vasodilation the blood pressure decreases. Now they also bind to the alpha 2 receptors which are present on the presynaptic nerve. So the alpha 2 receptors are located here. So as you can see here, here is the position. This is the presynaptic nerve. On that nerve, this kind of alpha 2 receptor is present. So what is going to be do? So this alpha agonist antagonist will bind with that receptor and block it. So what is the function of alpha 2 receptor? You clearly remember that the alpha 2 receptor on the stimulation with the agonist, it will decrease or it will reduce the activity of sympathetic vesicle to bind and to release the epinephrine, so it is decreasing it. Now we have blocked this receptor. So due to the blockage of this receptor, it will cannot decrease the and block the activity of a vesicle to bind with it. So in result, it is activating the vesicle to fuse with the membrane and to release the epinephrine. So therefore, due to the blockage of alpha 2 receptor, our epinephrine will increase more and more. So due to release of more and more epinephrine, what is going to be do? This epinephrine can bind with beta receptors. Okay, so beta receptor is freely available. We have only blocked alpha receptors. So the beta receptors like beta 1 receptor which are present on your heart, so this epinephrine will direct go to your heart, and in result it will increase your heart rate. Okay, now this process is called as epinephrine reversal process. So indirectly you have achieved a goal of decreasing blood pressure, but due to this process your heart rate as result increases. So this is process is called as